Hey everyone, so this is part 8 of the 2019-2020 SHSAT math test. So we're starting on question 107, so let's get started. So a student made a list of all possible products of two different numbers in the set above. What fraction of the products are odd? So to approach this question, basically we're being asked what fraction of the products are odd. So we need to know number of odd products that are possible over the total number of products. Okay, so basically to get the odd products, we need to remember certain rules of multiplication. So an even number times an even number is going to be even. If we have one even number and an odd number, that's still going to be even. And then if we have an odd number times an odd number, then that will be odd. And so basically, to get the total number of odd products, we just need to look at the cases where both numbers are odd. Okay, so the odd numbers here are 3, 5, and 7. So our odd products will be 3 and 5, 3 and 7, and 5 and 7. Right, and we're not looking at the cases like 5 and 3, because 3 and 5 and 5 and 3, they have the same product, right, due to the, I think it's distributive property of multiplication. So basically we have 3 pairs of numbers that have an odd product. So that can be, that's our numerator. And then the total number of products is going to be, so we have basically 5 choices for the first number, 4 choices for the second number, and then we divide by 2 because, like we said, 3 and 5 is the same product as 5 and 3, so we're counting twice. So we have to divide by 2. So the total number of products, therefore, is going to be 10. So it's going to be 3 over 10. So that's the fraction of the products which are odd. And that would be B. Okay. So 108, a number n is divided by 25. If the quotient is 10 with a remainder of 5, what is the quotient expressed as a decimal? Okay, so we know that our quotient is 10 with a remainder of 5. So first I want to express this as a fraction, and then we can turn it into a decimal. So 10 are 5. So if we have a remainder of 5, remember that that's out of 25. Because n is our number is divided by 25. So it's 10 and 5 25ths. That's what a remainder of 5 means in this case. So that's our fraction, right? And so now we need to express this 5 over 25 as a decimal. And to do this, we can multiply both sides by 4 to get something out of 100. So that this would be 20 out of 100. And then basically this is equal to 0.20 as a decimal. So therefore 10 and 5 25ths is just 10.20. So this is sort of our number, this is our decimal. So this would be E. So it didn't matter what the number was, it only mattered that it's divided by 25. Okay, so now we're on 109. So we have a garden design, which is shown above, and it's created in the shape of 3 semicircles whose diameters lie on the sides of an equilateral triangle. If each diameter is 2 meters long, what is the perimeter of the garden in meters? Okay. So first of all, the perimeter of the garden, I'm gonna outline it. So it's like this outer region, right? That's our perimeter. Okay. So we're told that each diameter is 2 meters long here. So basically this means this is one semicircle, right? And if it has a diameter of 2 meters, this is its diameter, right? So this is sort of our half circle. But remember that this is a semicircle, so this is like this half right here is sort of like the unseen part of the semicircle, and then this line here is going to be our diameter, and it's going to be 2. So if we look back here, right, this is our semicircle, this is the diameter. So this is 2, and by similar logic, this is 2, and this is 2. Right, so we see that the sides of our equilateral triangle are of length 2. And now we want to know what the perimeter of the garden is. So basically, I'm going to say that the length of this semicircle here, I'm going to call it L. So this is L. So we know that the circumference of this circle, if this is L, then this is L, right? So the circumference of the circle is going to be 2L. And we know that the diameter is 2. So we know that the circumference is equal to 2 times pi times the radius. Now, 2 times r, so 2r, 2 times the radius is the diameter, because the diameter is twice the radius. So we can rewrite this circumference as being just the diameter times pi, right? So we're replacing 2r with the diameter. And then the circumference, so we know that the diameter is 2, so circumference is just 2 times pi, right? Okay, so the circumference is 2 pi, and we know that, so if the circumference is 2 pi, we know that this region here, this semicircle, is half of the circumference. So 1/2 of the circumference, which is the same thing as L, is equal to 1/2 times 2 pi, and that would just be pi. So L is just pi, and so the perimeter of the garden is going to be 3L, right? Because this is L, this is L, and so that would just be 3 pi, and so that's going to be C. Okay. So 1 in 10. Micha is playing a game with 5 cards, numbered 1 through 5. He will place the cards in a bag and draw 1 card at random 3 times, and replacing the card each time, right? So he puts the card back in the bag each time. To win a prize, he must draw the number 5 all 3 times. Okay, what is the probability he will draw the number 5 all 3 times? So first we're going to look at the probability that he draws the number 5 once. So that probability is the number of 5s in the deck over the number of cards. Right, so there's only 1 5 in the deck and 5 possible cards. Therefore, the probability that he draws 5 one time is just 1/5. Now, he doesn't replace the cards, so 1 over 5 is the probability each time that he draws, because you're just drawing from an identical set of cards each time if you replace it. So to draw the number 5 all 3 times, we have to use our multiplication rule. So it's 1 over 5 chance the first time, 1 over 5 chance the second time, and 1 over 5 chance the third time. So this would just be 1 over 5 cubed, and that is just 125, and 1 over 125, and that's E. Okay, so the speed 10 meters per second is equivalent to how many feet per hour? Okay, so we have 10 meters per second, and we want to get this into feet per hour. So the first thing that we kind of need to know is, I guess we're given 1 foot is equal to 0.3 meters. So let's actually write this and see where it gets us. So 1 foot is equal to 0.3 meters. Okay, and we can sort of see that we can get feet per second by, so the meters in the numerator and denominator, they cancel out. So let's cancel those out. And then we would get 10 over 0.3, and then the units that remain are feet in the numerator, seconds in the denominator. And so we're pretty close now to getting feet per hour, but we want to have seconds in the numerator to hours in the denominator, so that these seconds can cancel out and we can be left with our hours. So we need some sort of conversion between seconds and hours. So we know that 1 hour is going to be 3,600 seconds, right? Because there are 60 seconds in a minute, 60 minutes in an hour, so 60 times 60 is 3,600. So now we can cancel out our seconds, and we're left with the correct units. So this would just be 10 times 360 over 0.3, and I'm just going to write that as 3 over 10. And this would be feet per hour. And we can just do the simplification. So this is 36,000 times 10 over 3. So this is 1. This would be 12,000. And then this would be 120,000. So that would be D. Okay, what is the value of the expression above, written as an improper fraction? Okay, so basically I'm going to, so I'm going to decompose each of these. So 6.34 repeating is the same as 6 plus 0.34 repeating, and then we're subtracting 4 plus 0.12 repeating. So remember that if we have this minus sign here, we have to distribute it to each of 4 and 0.12 repeating. So this becomes 6 plus 0.34 minus 4 minus 0.12 repeating. So we have 6 minus 4, which is 2, and then 0.34 minus 0.12. Okay, so now I'm going to try to express these as a fraction. So this is just, let's see. Well, let's see. Actually, I'm going to try to like write these in a repeating way, right? So we have 3, 4, 3, 4, 3, 4, repeating, minus 0.12, 1, 2, 1, 2, repeating. And if we actually do this subtraction, we get 0.222222, right? I'm just subtracting each digit here. And this is just 0.22 repeated. So basically, this can be rewritten as 2 plus 0.22 repeating. And now I'm going to... now I think the insight here is that you need to know what this fraction actually is, which is sort of unfair. Or not a great question. But okay, so this 0.22 repeating is just 2 times 0.11 repeating, right? Yeah. So then this would be 2 plus 2 times, and then 0.11 repeating, you might not know this, but I think this question sort of presumes it, is 1 over 9. You can check that, obviously. Okay, I'm going to erase some stuff. Okay. So now, this is just 2 plus 2 over 9, which is 2 and 2/9. And then expressed as an improper fraction, this would be 2 times 9 plus 2 over 9. And then this is just 20 over 9. So that would be H. Now, if you didn't actually know that 0.22, how to write that exactly as a fraction, what you could do is you could say, okay, this is approximately like 0.20, and then here, let's erase some of this. Yeah, so this is approximately 0.20, and therefore we have 2 plus 0.2, and this is, 2 and 2 over 10, and this is 2 and 1/5, and as an improper fraction, that would be 11 over 5. And then you could take this and you could sort of compare it. You could sort of compare 11 over 5, the value of that, to each of these answer choices and see which it's like closest to. Actually, that's not great given that 20 over 9 and 24 over 11 are pretty similar. But so you kind of really do need to know what this fraction turns into. So I don't think it's a great question, but whatever. But it's just sort of like a memorization of decimal fractions. Okay, so 113, let's see. Yeah, why don't we finish this up? Yeah, let's finish it. Okay. So we have this graph here, and lines in S and T intersect at point P35. What is the area in square units of the shaded region in the graph above? Okay. So this like shaded region, it doesn't look very friendly in terms of an area, because this shape of the shaded region is not really familiar to me. I don't know how to calculate the area of that directly. However, what I see here is I see that we have this sort of bounding rectangle here, And if you look at sort of this triangle right here, I'll call that triangle A, and then this triangle B right here. So if I take the area of this rectangle and I subtract out the areas of the triangles, then I can indirectly get the area of this shaded region. So let's actually do that. So the area of the rectangle is just its length, which is 5 times its width of 3. So that would be, so we have 5 times 3 is that area. Here, I'll write that sort of like here. And then let's find the area of B, triangle B. So to get triangle B, we need to get the length of its base and its height. So I'm going to say that its base is sort of like this. So that would be, we're going from 1 to 5, so that's 4. And then its height would be going from 0 to 3 on the x-axis. So that's 3. And then we need to divide by 2, right? So that's 4 times 3 over 2. So that's the first area that we're subtracting. Right, so we're taking this rectangle and we're subtracting out the triangles to get the shaded. So then we need to find the area of A. So its base is from 1 to 3, so that's 2. And then its height is from 0 to 5, which is 5. So we have 2 times 5 over 2. Okay, and so we're going to simplify. So this is 15 minus 6 minus 5. So that would just be 4. So that would be C. Okay, and then our final question. A box contains 14 red marbles, 10 black marbles, and 16 white marbles. How many more white marbles need to be added to the box so that the probability of randomly drawing a white marble is 3/5? So let's figure out the current probability of drawing a white marble. So there are 16 white marbles, and then the total number of marbles would be 16 plus 14 plus 10. So that probability would be 16 over 40. And let's simplify that while we're at it. So divide both sides by 4, we get 4 over 10. And then divide both sides by 2 to get 2 over 5. Okay, so actually, you know what? Simplifying it isn't good because it is misleading. So it can lead to an error. So we have because we have 40 marbles and 16 of them are white. And we want to add some white marbles, right? We want to add, let's say, X white marbles, so that this new probability of drawing a white marble is 3 over 5. Right, so if we add X white marbles, the total number of white marbles increases, and so does the total number of marbles in general, right? Because if we add white marbles, that increases the total as well as the number of white marbles by X. So this is our new probability of drawing a white marble, and we know that this new probability has to be equal to 3/5, and X is the number of white marbles added. So now we just need to solve for X, and I'm going to do this over here. Okay, so basically I'm going to solve this by cross multiplication. So I have 16 plus X times 5 is equal to 40 plus X times 3. And now I'm going to apply the distributive property. So 16 times 5, that's going to be 90. 5 times X is 5X. And then 40 plus x, so 3 times 40 is 120. 3 times x is 3x. So now I'm going to subtract 3x from both sides to get 2x plus 90 is 120. And then 2x is equal to 30. So x is 15. Okay, and that's I guess not one of our choices. Oh yeah, let's see, what did I mess up on here? So there are 16 white marbles, right? And then the total number would be 40. Yeah, so then we need to add some white marbles. So yeah. So let's see, maybe I did something wrong with the, oh right, okay. So 16 times 5 is, when we do this distribution, 16 times 5 is actually going to be 80 instead of 90. So 80 here as well. So then 2x is going to be equal to 40, and then x would be equal to 20. So that would be h, and that would be our answer. And so we're done with the test, and yeah, I hope this was helpful. Okay, bye guys.